nature nut, I'm not afraid to admit. I'm wild about the wild things and I'm proud of it. I'm just a simple case, open and shut. No doubt about it, I'm a nature nut. Today we'll go bird watching, tomorrow we'll catch toads. The next day we'll take photographs of bugs along the road. I never get the feeling that I'm in a rut. That's why I'm a nature nut. Well, I'm a nature nut, I'm not afraid to admit. I'm wild about the wild things and I'm proud of it. I'm just a simple case, open and shut. No doubt about it, I'm a nature nut.
The microscope, the wonderful invention of Antoni Van Leeuwenhoek, whoever he was. You know, when I was a kid, I used to love my microscope so much, I would stare through it for hours until my right eye became so bloodshot my folks had to take the microscope away for a couple of days so my eye could recover. In those days, the microscope, the white lab coat, the nerdy glasses, those were the symbols of science, and we were all introduced to them through those peculiar, uptight science films that they used to show you in the classroom, the ones that were made in the 50s and 60s. But you know, the more things change, the more they stay the same.
Microscopic life, it's all around us. The idea that each and every drop of pond water contains within it tiny, weird animals has had, it seems historically, a life of its own. It is a tiny world, a minuscule world, one might say, and a world which is only visible with the aid of a microscope. Why am I telling you this? Because we are going to spend the next half hour searching through the universe of muck, slime, ooze, and corruption in search of protozoans, rotifers, gastrotrichs, and other minuscule organismal life forms. Sound exciting? You betcha.
Okay, well, let's get the dirty stuff out of the way first. In order to find yourself some good microscopic life forms, you need, first of all, a source of scummy water. Now, any source will do. Find yourself a pond, some source of, you know, stagnant, slightly efflorescent water, and I'll just, efflorescent, that's probably not the right word, but you know what I mean. Stinky water. There's some stinky water, not quite enough stinky water. I'll get a little more. It's scummy, but it's not scummy enough. Reach into the pond, have no fear, grab yourself stuff like this. Rotting vegetation is excellent, so is algae. Any of that sort of, anything that looks green and horrible, anything that convinces you that you should wash your hands after you do that, and that's exactly the kind of stuff you want. This will be a source of many hours of enjoyment for you at your microscope. Now that's the first method for obtaining yourself a protozoan culture. The other way to do it is to produce an infusoria jar, or an hay infusion they call it. And for that purpose you just take another glass jar, get some water in it. Doesn't matter what kind of water, any kind of water except tap water. Remember that they put chlorine in tap water to kill exactly the sorts of creatures that we are after. And once you've got that, just get some dry grass and stuff it in the water. On the leaves of dry grass, there are little protozoan cysts, little dried out protozoans that will come back to life once they get wet. And I would take this jar home, put it maybe on the garage windowsill, someplace where you don't mind it if it gets a little bit smelly, and leave it sit for a couple of days, up to a week, and then, oh boy, it will be full of critters, a real source of joy. So, there are your two methods. Basic pond scum, hay infusion. You take your pick, either one will work very nicely. There are more than 50,000 species of protozoans known to science, and new ones are being discovered at a rate of one or more per day.
According to most sources, the microscope was invented by me, Antoni Van Leeuwenhoek. It's not really true, but I am now famous, and this is my microscope. I'm famous, but almost no one can pronounce or spell my name correctly. The microscope was actually invented before my time. Many other people had microscopes. The distinction that I claim is I was the first person ever to look at anything interesting under a microscope. I don't know what those other people were looking at. Their fingernails, probably. Something like that. Still happens. Give people a microscope, they look at their fingernail. My microscope's very easy to use. You put a drop of water on the end of that little point there, hold it up like this. This is the focus knob. Aim yourself at a source of light, and you can see whatever is in the drop of water. My most famous moment came in the year 1674. I went down by a pond in my native country of Holland. I picked up a drop of water. I looked into it, and I said, "Ah!" because there were weird tiny animals in that drop of water. It surprised me, it surprised my friends, but thus was born the science of protozoology. As it turned out, just about any drop of water could contain tiny, weird animal life. A fact which I personally found fascinating. Most other people at first were skeptical, but soon their skepticism changed to fascination, and they began to visit me, come to my house and say, "Antoni, may I look through your microscope?" Even some royalty came to visit me. I had to make little sandwiches, cut the crusts off, pour drinks. It became quite a pain, but this is the price of fame. A single drop of pond water can have hundreds of protozoans in it. The average pond has more protozoans than there are people on Earth. This, believe it or not, is a microscope. It's not an expensive microscope, but it is a microscope. And if you can use a microscope on a picnic table, you can use one just about anywhere. I've just been looking at this slide. It's a slide of a P. persimilis mite with the Guillem's stain. You know, oftentimes when you buy a microscope, you get these prepared slides with it. They don't often make much sense, and they don't move. They're really quite boring. Everybody wants to make their own slides, of course. So let me show you how to make a slide of some living microorganisms. Now you could, of course, use a regular microscope slide, just a flat piece of glass, and cover it with, put a drop of water and cover it with a cover slip, which is a smaller piece of glass, but that's a pain, and those little cover slips are very delicate and they tend to break and cut your fingers. So instead, I've got what's called a depression slide, and this is a plastic one. You can't break it. Very safe. It has a little depression in the top, and what I'll do is take an eyedropper, stick it in my scum sample, get some water, put a little drop in the depression, and then you place that on the stage of your microscope. The stage is the part where the slide goes, and it should have little clips to hold the slide in place. So what you need to do now is to make sure that you have some light coming through your microscope. The microscope has a little mirror down here, and the mirror will reflect light up through the lens. Now, you don't want to reflect the full light of the sun up through the lens. That's bad for your eyes, really bad for your eyes. So just get a bright part of the sky, and hey, I mean, the sky is usually bright, and reflect that light up into your microscope, at which point all you have to do is focus. Now on this microscope, the focus knob is down here. Every microscope is different, but they all have a focus knob. Look through. Now if you get into this the way I hope you will, one of the things you'll have to watch out for is eye strain. Getting one very bloodshot eye by the end of the day, by the end of a long session at the microscope. The way to avoid it is try not to squint into your microscope like this. Instead, keep both eyes open. Now that'll feel uncomfortable and unusual at first, but once you get used to it, you'll find that it makes you a lot more comfortable by the end of your session, and if anything interesting happens down by your feet, you won't miss it. And ho-ho, yes indeed, there are some sort of little protozoan creatures in there. Very good. That's all there is to it. And at that point, the only thing left to do is to learn how to move the slide around. Just touch it very gently and it will move, but you'll notice that when you poke it to the right,
it looks like it's moving to the left because the image is backwards in the microscope. Gets a little confusing at first, but you'll get used to it. And after you've had a little practice, you can follow whatever little animal movement you have in front of you without too much difficulty. Most protozoans reproduce simply by splitting in two.
All right, well, let's have a look at a few of these little critters and see what they're up to. If you watch protozoans especially, most of what you'll see is a lot of swimming, some eating, and the occasional bit of fission, you know, when they just divide right down the middle to produce two where once there was one.
Oh, and that's a great view of paramecium. That's a ciliate protozoan. The cilia are the little hairs on the outside of the body that propel it through the water, and nobody seems to be dividing here. They're all just probably feeding or looking for food. It's kind of neat the way they bend around corners, isn't it? Ooh, that's nice. And let's just have a look around here. Change power, scan for some. Oh, wait a sec. What's this guy? Now this one doesn't have cilia on the body. It has a flagellum. It's a flagellate protozoan, but you can't see the flagellum. It's a little tail because it's too thin. You can just see a little bit of a water current around the tip of it, or at least I can see that. Maybe you can't. What else have we got here? Oh, on the back of that plant leaf, it's a rotifer. Yes, it's a rotifer. You see how the way it's moving there? Oh, very cool, very cool. You're going to like rotifers, but this one is hard to see. I don't think we can get in close on this one because it's just a silhouette. Let's try scanning, get a focus, and oh, there's a nice one. This one is feeding. The head just kind of opens up. This is not a protozoan. It's a multicellular animal, but it still has cilia on the head, and the head opens up to feed just like a little electric shaver. And when that happens, there it goes. You see the water currents coming all around the head, and the animal is filtering all the edible gunk from the water around it.
Remember when you're looking at these protozoans and other single-celled creatures and microscopic creatures, that even though they are tiny, that doesn't mean that they are simple, and it doesn't mean that they are necessarily primitive. They actually, as even the single-celled protozoans, have structures that are equivalent to a muscle system, to a nervous system, to a digestive system, and they can do all sorts of things that we think only larger animals can. After all, they've been evolving for the same period of time as anything else. They've been on Earth for the same number of billions of years. We seem to have a bias against protozoans, and I think that comes from things like comic books and monster movies. We think of them as little tiny monsters, which, if they were larger, would be a big problem for you and I.
For a protozoan, swimming through water is kind of like a human being swimming through molasses. At that size, water feels really thick.
Why do you suppose that most nature-loving people possess a pair of binoculars but not a microscope? Could it be that distant organisms, distant subjects for observation are more interesting than tiny ones up close? I think not. Did you know that the era of the home microscope is upon us? It began in the 1950s during the Sputnik time, when the home microscope and the home chemistry laboratory first came into fashion. Well, let me tell you a few things about home microscopes so that you can choose the appropriate model for your own needs. This is a professional microscope, and without any doubt, the earliest models of home microscopes were simply scaled-down versions of a professional microscope. They were fine, they were very serviceable, but nowadays, home microscopes have taken a variety of different forms. The purpose of a microscope, by the way, is not only to magnify an image, to make it appear larger, but also to resolve. In other words, to allow you to examine fine, fiddly details in your specimens. All of these microscopes are able to magnify 100 times quite nicely. Anything more than that, it's just a blur. This microscope can resolve extremely fine details. These home microscopes cannot. Any of them can be had for about $20, perhaps cheaper if you go to garage sales, but let me point out a few features you might like to watch for. If you intend to observe living specimens in drops of water, you will want a microscope with a stage which is, as we say, flat. A slanted stage, as we see in this microscope here, encourages the drop of water to drip off the slide and onto the base of the microscope. Now, that is not good unless you prop up the back of the microscope with a book. This microscope, well, the entire microscope falls off the stage. It also requires a battery, and the battery wears out. For that reason, I prefer this sort of microscope and this sort of microscope. A flat stage, the stage is where you put the slide, remember that, and a simple lens which magnifies approximately 100 times. And thus, for a modest expenditure of some $20 or less, you too could possess a home microscope, the key to unlocking a universe of adventure and discovery, one of the great bargains of our time.
A few types of protozoans cause diseases, like malaria, but most of them are free-living and mind their own business.
If I was a little protozoan, I'd always keep my motor going, yeah. And if I was an itty bitty amoeba, I'd say to myself, arriba, arriba. Long-time resident Mr. Euglena says life in the pond couldn't get much meaner. If that was me, I tell you what I'd do. I'd live for today before I split in two. Life under the microscope, I wonder how those critters cope. 1 minute you're spinning your flagella, the next you're devoured by a vorticella. Compared to them, I'm as big as a whale. I don't think I'd like it at their scale. Ignorance is bliss, but the fact remains they're too tiny to have brains. If I was a little rotifer, I know just where I'd go to forget. Forget my troubles, throw away my cares. Living in the moss with the water bears, yeah. When you are microscopic, the most interesting topics are swimming, reproducing, and of course eating. Life in the pond can be so fleeting. Life under the microscope, well, I wonder how those critters cope. 1 minute you're spinning your flagella, the next you're devoured by a vorticella. Compared to them, I'm as big as a whale. I don't think I'd like it at their scale. Ignorance is bliss, but the fact remains they're too tiny to have brains. Life under the microscope, I wonder how those critters cope. Ignorance is bliss, but the fact remains they're too tiny to have brains.
When it comes time to identify your microscopic critters, you can't get too fussy about it. It's not like birds or butterflies. You can't identify each individual species, but you can figure out what general sort of creature you're looking at. Let me show you some of my own sketches. I hope you like them. This is, well, it's a protozoan. It has only one cell in its body, and it has a long tail on the end of it, which is called a flagellum. The end of that flagellum goes wiggy, 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 and that propels this critter through the water that way. A protozoan with a flagellum is called a flagellate protozoan. Makes sense to me. Here is a protozoan with little furry bits all around the outside of its body, and when those wave in the water current, the protozoan swims. These things are called cilia, and this is therefore called a ciliate protozoan, silly as that may sound. This thing is also a ciliate protozoan. It has a long sort of stem that sometimes curls up. This one is called a vorticella. And here we have a protozoan with neither cilia nor flagella. This one is just a blob, and those ones are often amoebas. This one is in fact an amoeba, or at least it's a picture of an amoeba. How about this? A little round dark circle with a light center. It's an air bubble. Don't be fooled by air bubbles. They never move. Okay, let me show you a few other things you might encounter in your time with the microscope. If you look into the lens and you see these heavy lines on the top and the bottom of your field of view, they are your eyelashes. Back your eyeball up and you will no longer see them. That's a common problem, but nothing to worry about. Now, on the other hand, how about this thing? Ooh, if you could only be so lucky to see some of these. Occasionally I find them in the filter for my fish tank. Those are gastrotrichs, or this is a gastrotrich. This is a picture of a gastrotrich. Gastrotrich means stomach hair, but I don't know why it means stomach hair. They're little peanut-shaped things, and they swim this direction, and they're very cool. This is a rotifer. What's a rotifer? It's to drive your car on. It's also a multicellular, tiny microscopic creature in the phylum Rotifera. And on this rotifer, that's the foot that it will stick to, you know, a piece of plant material or something like that. This is the head, and the cilia around the head beat and sweep food into the mouth if the foot is attached. If the foot is not attached, when the cilia on the head beat, the rotifer swims through the water, like that. And hey, it's very cool. There are many different kinds of rotifers. And how about this one? It looks like a little doggy or something. These ones are called water bears, and they live only in mosses. They're really hard to find, and they're quite tiny. I mean, they're smaller than most protozoans, but look at that. It even has a little eye and these little clawed feet. Very cool. Dried up water bears can be frozen, they can be really frozen, they can be heated up, they can be left for years, and they'll still come back to life when they are rehydrated.
Well, there you have it. The world of microscopic organisms, the world of weird tiny animals. The world is there for you to explore, to enjoy with your own microscope. And I must say, microscopes have improved some in the last 300 years, although they are now quite a bit heavier and more difficult to hold up to the sun. Still, I like them. Until next time, I'm a nature nut, and I hope you are too.